Okay, it's 7 o'clock. We'll go ahead and get started. I see we have over 42 people already present. We had nearly 100, or actually a little over 100 who pre-registered. I'm sure people will continue to come in, but I'd like to get started. We have a lot of exciting information to share. And my name is Dwayne Shaw, and I'm the executive director of the Downeast Salmon Federation. And tonight we have Zach Scheller, who's our hatchery manager, and Brett Ciccartelli, who helps us with technology, communications, and many other things. So Brett will be in the background here helping move the slides along. Thank you everyone for showing up, and it's exciting to see so many of you. I know quite a number of you, and many great supporters amongst you out there. So thank you for all of your support over many years. We're going to be talking about the Peter Gray Parr project, which has now been underway for 10 years, and we had begun building the facility even before that. So, and of course, we'd been working in the watershed prior to that point as well. So we have the slides here. We're going to take just an hour. We'll have some questions at the end. We're going to cook right through this because there's a lot of information, and we advertise this as information about a breakthrough. And there's a number of breakthroughs related to this project, scientific breakthroughs, partnership breakthroughs. The results of the work has meant that a wide adoption of the approach. Oh, Brett, we've lost the slides.
Yep, sorry guys, I'm just gonna do one thing here. I gotta share my screen differently to make sure I can still let people in the room. So hang tight, here we go. Now, Dwayne, can you see him?
Perfect.
Great.
You can go to the next slide. So the Downeast Salmon Federation has been in existence since 1982 in Washington County. We have a number of programs, as many of you know. We do both the hatchery work as well as watershed restoration work and community engagement collaborations across a number of topics. But you see on the photo on the left, that's the dam on the East Machias that we removed about 20 years ago, which led to the hatchery being built at that location just downstream. Our goal is to restore a fishable population of Atlantic salmon. Next slide. In order to achieve that goal, we've taken this multi-pronged approach. You can go to the next slide, Brett, if you can. Can't let people in and move the slides at the same time.
That's what it seems like here. Hold on a second, Dwayne.
Okay.
I don't know what's going on here. I'm being overwhelmed with people logging in, so.
Well, I can continue to talk as we let more people in. So this work began with the hatchery, as I said, back in 2000, about 20 years ago, when we took ownership of the former hydroelectric station, power generation station in East Machias that was associated with the dam. This is a very large experiment, long-term experiment, looking at the results of this particular method of stocking, of rearing the fish and then stocking them into the East Machias River, just to the east of the main Machias River. We're seeing great results. As you see the second bullet here, it sees what we're seeing is return rates up to 14 times what you would see using, for instance, smolt stocking on the Penobscot is where that number comes from. The naturalized approach, and we don't have all of the proof of this, but the concept is that a more naturalized approach to rearing the fish in the river of origin using river-specific native genetics while you're repairing also the river are the basic ingredients of why this is working so well. The agencies have been very big partners in this with us, other non-governmental partners in water restoration, watershed restoration, and the North Atlantic Salmon Fund, the Atlantic Salmon Federation, Project Share. So just briefly, because we have a broad audience, I wanted to, we can go to the next slide, please. Just a quick bit of information about the Atlantic salmon, since not everyone is completely familiar with this. Atlantic salmon in Maine tend to live in the river for about 2.5 years before they migrate out to sea. They would migrate all the way to the Arctic, to Greenland, where they mature. That takes about 2.5 years, and then they come back. They'll come back 8 to 12 pounds the first time. Atlantic salmon don't necessarily die after they spawn. They can repeat spawn, and that comes as a surprise to a lot of people. They come back to the river of origin and often to the very same tributaries where they were born or placed as at different life stages. So you see fry on the right-hand side here, fry, parr, smolt, adult. The adults lay the eggs in the gravel, and then those young alevin eventually come out of the gravel as fry. What we're talking about is parr. So these fish are, they would hatch in April, May, come out of the gravel at that point in time. In our case, they're in the incubators in our system, very unique incubators. And then we raise them up until October and release them. So they're not a year old yet when we release them. So they spend another 1.5 years or more in the river before they go out to sea as smolts. So that's the basic life cycle. Next slide, please. So the people involved with this initially were Ori Vigfusson of the North Atlantic Salmon Fund, and Ori worked all over the North Atlantic in recovery of Atlantic salmon, protection of Atlantic salmon, and in that process, and I'll say he also served on the board of the Atlantic Salmon Federation. So Ori was from Iceland. He traveled a lot and looked for solutions, and one thing that he came upon was the tremendous recovery of salmon on the Tyne River. Now, we've lost the slide. I will continue to talk. So that Peter Gray was essentially discovered by Ori. Ori spoke with some individuals from the United States, particularly the Grassy Creek Foundation, about sponsoring Peter to come to North America and find an organization to work with to export this technique. Because of the tremendous success on the Tyne, a river that was essentially deemed dead, and very, very little fishing was allowed at all. And there was very little successful fishing because there were so few fish. Ultimately is now, I believe they consider it the best salmon river in all of England, and it's rivaling rivers in Scotland. So Peter, this particular photo of Peter, I find pretty telling of who he was and the skills that he possessed. So he was had dropped out of school in the 8th grade to become a coal miner, like many people in his family had. He hated the coal mines. He loved being outdoors and with animals. He became a game warden or a bailiff, and then ultimately ended up working in the hatchery system. But he considered himself a stockman. So he really studied the husbandry of animals and the judging of, in this case, he became a judge of fancy fowl. And what I like to say is that he used the same skills at the opposite end of the spectrum with Atlantic salmon, where you want to keep these fish as wild as possible. However, you're still in control of them in the hatchery environment. What we're looking at here is highly domesticated fowl, and the other opposite end of that was the naturalized approaches of rearing Atlantic salmon. So kind of the same skill set applied across a very broad spectrum. And his little byline he would often talk about was, we have to raise little athletes. They have to be able to survive in the wild. So you've got to toughen them up. So we raise these fish in the river of origin, no filtration, and we'll talk more about that in a moment. On the right, you could see Peter with then hatchery manager Jacob Van de Sandy, when we first sort of verified that using the techniques in the East Machias would work. We would produce fish that were very much wild-like in their size, shape, color, and so on. And unfortunately, both of these gentlemen have passed away. However, the good news is that they were able to transfer this technology and keep this, build the momentum that we've been able to run with since. Next slide. I love this video. This was just sent from an angler on the Tyne River. What you're looking at is what was once a dead river. This is, I believe this is downtown Newcastle. This is an industrialized river. This is not a wild, untouched landscape like you might find in Alaska or maybe some places in Scotland that don't have a lot of development. So you can see why the anglers are very, very happy over there. It's quite the opposite of what I've experienced in my 20 years or more working here with Atlantic salmon. Clubs and landowners and so on, all very energized by the fact that they have one of the best salmon rivers, and it was once polluted and essentially dead. Next slide, please. So this project is based in some really important modern science, as well as some very simple practices of rearing the fish. They're in combination. It's a whole, and that the whole is based upon this genetic concept that the fish themselves, or the facts of the matter, are that these fish are river specific. They're wild. They need to remain as wild as possible, and we need to work with the native genetics. So in doing so, we're working with U.S. Fish and Wildlife Service. They maintain a live gene bank. The eggs that we receive come in from the live gene bank at Craig Brook National Fish Hatchery, and those fish are screened to verify that there's no aquaculture escape genes in there or other genes that might show up. So these East Machias River specific fish that were captured in the East Machias, raised to maturity, and then we receive the eggs, fertilized eggs. The project itself has been a big partnership with Maine DMR, NOAA Fisheries, in terms of the assessment, the support. The smolt traps that we use are owned by NOAA Fisheries. DMR is deeply involved at all stages with us. And for us, what we refer to this as co-management. So we're a non-governmental organization working cooperatively to manage the recovery of this important species. Next. This is the dam that we removed, and this is the building that we took ownership of from Bangor Hydro. It was abandoned. There were pigeons living in it. It was really a mess, but we had a vision, and I have to say, many people told us we were a little crazy, but now 20 years later, we've proven that it was well worth the investment that we've all made. Next slide. As you can see, there's been a history of dams on the river going way back. This is early 30s, just when that dam was built, that we removed just below Route 1. And as you can see, there was no water going down the fishway in those days. So the native strain salmon were never lost completely, but they went through a lot of difficulties over those many years. We ultimately removed the dam, as you can see here. Next. That's the facility now. You can see the chimney. That's everything else has been disguised. We've encapsulated the cement cinder block building, made it look like it should in the setting of it's beautiful downtown East Machias, the historic district of the downtown. And we're using solar in part to power the facility. Next. Inside the hatchery is an exact and somewhat smaller version of the Kielder hatchery on the River Tyne. And when Peter came in Ori and talked to us about a partnership, Peter was very adamant that we would use the exact same techniques, that this needed to be tested in another setting. He did not have the benefit of doing the vast amount of assessment that we've done. So it was, in our case, we had the benefit of having the funds and really the necessity of documenting everything. So what we're after is the most wild-like Atlantic salmon Parr that we can produce. Size, like I said, size and shape. The elements of the hatchery are, like I'd said, no filtration of the water. We use substrate incubator that replicates the wooden box that you see there, replicates the river bottom, black tanks, accelerated flow of the water, and then the native genetics. Next. So this is where Zach is going to pick up, and we're going to talk about some of the history of stocking on this river and compare it over time, but also then we'll talk about other rivers in real time now as we ran this project. Zach is muted.
Thanks, Brett. I think you got me now. All right, thanks, Dwayne. So yeah, this just shows that over time, the East Machias has actually benefited from having fairly segregated types of supplementation to the river, i.e. where the baby fish are coming from in the river. So back in the 70s all the way up into the 90s, the East Machias was pretty much solely stocked from natural spawning. So that would be fish coming back from the ocean, digging reds, and fry emerging from the gravel. Then for a few years in the late 90s, they did some fed fry. So that would be fish that had recently emerged and were fed for a few weeks before being stocked out. And then from 2001 through 2011, the river relied on unfed fry. So this would be fish right as they had switched from being alvin into fry, being put right out in the river. So fish are pretty tiny at that point, maybe an inch and a half long, and the river can also be quite big in May. So whenever you put small fish, water, and maybe conditions that don't line up exactly right, you can have some issues with fish not making it. There was also a small section of time where adult fish that were ready to spawn were put out into northern stream and allowed to spawn to try to generate baby salmon. Since 2012, the river's been pretty much stocked just with fall Parr from the Peter Gray hatchery. And when we look at numbers for e-fishing and stocking, we're essentially comparing the results of Parr stocking to the unfed fry stocking that happened for the first decade of the 2000s. Go ahead, Brett. So when we stock our fish in October, we stock clear across the drainage. So on the left hand of your screen, you can see the East Machias watershed. Those red dots you see are stocking locations, and we stock salmon into mapped salmon habitat that's been mapped by the Maine DMR. And those would be your tributaries northern and beaver dam, CV, but we also stock a lot of fish into the main stem of the East Machias. So this gives us a drainage-wide stocking, which allows those fish that have the natural genetics from the river be able to live all throughout the river, and the genetics that are the right ones survive to be smolt. We also stock high densities of fish. Instead of maybe putting 20 fish out per habitat unit, which is 10 by 10 meter square, we'll put 150 or 180 fish per unit out. Since 2012, we stocked almost 1.3 million fall parr into the East Machias River. Go ahead, Brett. So as Dwayne mentioned earlier, what we found through our sampling is that Peter Gray parr produce smolt and eventually adults that return at rates higher than other stocking techniques used in the state of Maine. And we get to that crescendo of that data through a few different ways, for juveniles, smolt counting, and bred counting. Go ahead, Brett. So electrofishing is pretty simple. You strap a battery onto your back. You have a positive end and a negative end, and you send electricity through the water. What this does is stun the fish enough to allow the two people with nets to net the fish up. It allows us to not only get the numbers of fish in that section of river we're shocking, but also look and see how the fish are doing. Are they healthy? Are they fit? Are they sick? Are they skinny? Are they fat? You know, all those sort of things is what electrofishing tells us. If you look at the graph, the blue lines, or the horizontal, the three blue ones and the red one, those are what's called a decadal median. So that's basically the median, which is a type of average for that section of time. And all of those blue lines would be from natural spawning and unfed fry. And then the red lines and the red dots are from fall parr stocking. So as you can see, we've had quite an increase since we started stocking fall parr into the East Machias. We've actually had the highest number of juveniles seen in the river since the late 1970s, and we've more than doubled the median number of fish we see versus unfed fry. Go ahead, Brett. So they live for a couple years in the river. Salmon go through this process where they switch from breathing in fresh water to breathing in salt water, and that's called smoltification. During this time, they switch from their camouflage of the river to silver camouflage for the ocean and start heading out to a sea. In the upper left, you can see our rotary screw traps set up. Those are big cones that spin in the water with the flow of the water. Fish they swim in the front of it and get funneled down into a live car. That's tended each morning. And we count how many smolt we have, and we also get lengths and weights and genetic punches and scales. That gives us the ages of the fish. And since our fish that leave our hatchery, if they're missing their adipose fin, we can also tell for a fact that they came from the stocking of the Peter Gray hatchery. And the graph on the right, you can see the general trend is an upward movement of the number of smolt leaving the East Machias River. In fact, now we only have 1 year of data for what unfed fry would have as smolt, but that would be around 300 fish. And, you know, as a general rule, we produce around 1,200 smolt. So we've quadrupled the number of smolt heading to the ocean. Go ahead, Brett. So then once the smolt head up to Greenland, as Dwayne mentioned, and hang out for a couple years getting big and fat, eggs, they come back to the same river that they were born. And often they come back to the same stretch of river that they were born. So each November and December, we head out in canoes, standing up for better visibility, and head down all parts of the East Machias River and its tributaries, looking for places where salmon. So the picture on the left, you can see the red circle around the lighter colored gravel. So in the right-hand side of that picture is a pit, and that's the pit where the female salmon dug a hole which covered the eggs she laid behind with the gravel. So those are what we're looking for as we go. And, you know, in great news, like in 2019, saw 60 reds in the East Machias. That's the highest number seen since the late 1990s. And counting these number of reds also leads us to the next slide, where we have estimated the number of smolt heading to the ocean, and we count the number of reds we see, and those two figures work in to give us a smolt to adult return rate. Easier said, marine survival, or how many of the smolt survive to come back and spawn as adult fish. And that bright green line at the upper right hand corner of the graph, that's from the Peter Gray Parr project in the East Machias. The blue line along the bottom, that would be from stocking that occurs in the Penobscot River. So just as comparison, our average smolt to adult return rate is around 2%. So 2% of the smolt that leave come back to spawn. That blue line for the Penobscot averages around 0.1%. So that's where you kind of get the 14 times more fish returning to spawn as far as a proportion of the smolts that left. The green line, the darker green lines you see, that's the Narraguegas River, which is actually a river we just started. This is our first year growing Parr to supplement that river. That averages around 1%, and that would mostly be from natural spawning and unfed fry. So the Peter Gray Parr project is, supplement places with Peter Gray Parr. You increase the number of juvenile salmon in the river, you increase the number of smolt, and you increase the number of adults returning, which is great. That's what the whole goal was. Next slide, Brett. I'll switch back over to Dwayne here to talk about the last few slides. Sorry, bear with our technical difficulties. So seems like Brett's having a bit of an issue unmuting Dwayne. So I'll kind of continue on, I guess, since I'm unmuted. So the cool thing about doing the Parr project for the past decade and seeing the results we've seen in the East Machias, which is one of the smaller salmon rivers in the Downeast Shrew, and obviously much smaller than a river like the we've seen such good results that the agencies, U.S. Fish and Wildlife, Maine DMR, and NOAA, they've come up with a new stocking plan for this region of Maine, and it focuses heavily on using fall Parr to supplement the larger width classes of streams. So all headwater streams are called A width class. What we found is that Parr do as well as unfed fry, or unfed fry do just as well as Parr. But as we get larger, so into B width class, which would be like 6 meters to 12 meters wide, Parr outperform all other stocking strategies that have been used in that type of habitat. So if you have rivers that have thousands of empty units of habitat, and we can grow fall Parr to stock those units of habitat, then all of a sudden we've just increased the number of salmon in the rivers, which increases the smolt and eventually the adults. Our smolt production in the East Machias is about just below 1 smolt per unit. So if we stock 4,000 extra units of habitat, then we just increase the smolt population in Downeast, Maine by 4,000 fish. That's very generalized, and obviously there's a lot of variables, but that's the general gist. So because of that, you know, this stocking, the collaborative management strategy group for the region of Maine came up that they want to put Parr in B with class, C with, D with class.
Yeah, I'm set.
So I can switch over to Dwayne now if he's unmuted if you want.
Okay. Thanks, Zach. Great job covering those. And I think that part of the breakthrough that we're talking about here is exactly what Zach just covered, and that is that with the agencies coming out with the new stocking protocols informed by the work that we've done here, they've asked for a broad adoption of this method. So we've provided the proof of concept, and now it is ready to be adopted at a larger scale. Part of how that's occurred in just the last few months is through a grant that was issued to the Downeast Salmon Federation, a challenge grant to scale up, increase the production of Parr using this method, and to expand it to the nearby Narraguagus River. And that challenge grant is what a challenge grant means in this case is that for every dollar they are offering, we need to raise $1, and we need help. And the success is leading to a lot of attention, and we've already begun to, as you can see in this slide, get to the goal of what we need to be, $751,000 of private source funding to match this. We've had close to 2,000 individuals contribute to this, and foundations, family foundations, and so on, to this effort over the last 10 years. And in order to expand it, we need your help. And these challenge grants are very, very competitive. It's scientifically driven. They're also looking for buy-in from the community. And in this case, it's Eastern Maine. Eastern Maine is home to 5 of the rivers left in the United States with endangered Atlantic salmon. The Downeast Salmon Federation has a small fry hatchery on the Pleasant River, and we don't have the capacity now to expand that, but that would be the next phase as soon as possible. So for the next 5 years, we'll be stocking the East Machias and the Narraguagus using this method. And if at all possible, we would expand the Pleasant River and potentially be able to raise fish there for 2 additional rivers. Brett is, yeah, so this is the contact information. Sorry, okay, there we go. We would love to have your support or additional support. Many of you are already been supporting us for many, many years, some of you for a couple of decades even. This is super important. It's a huge breakthrough. The other element of this breakthrough for us is the incorporation into the endangered species program as a whole. So in order to do this work as a non-governmental organization, we need permits, many different types of permits, one of which is through the federal U.S. Fish and Wildlife Service, and that is to raise and rear and release and ultimately assess also their smolt trapping and other electrofishing and other things that we're doing with a standalone permit. So after all these couple of decades of work that we've been doing, we finally now have our own standalone permit. We have the challenge grant, we have the facilities, and we need the continued support of our members and supporters to expand this. The great thing about this is that it can be done anywhere, we believe. It could be done on the Penobscot, the Kennebec. It was done on the Tyne, and it could be done in rivers in Canada. So we have some time for questions. We've gone through those slides pretty quickly, which is good, allowing more time for questions. There is, on your screen, you'll see reactions, a button that says reactions, and you could also type a question in to the chat room. You can, we're recording this, and if your question isn't answered because of time, or if you have follow-up questions or any other comments or thoughts, you can certainly get in touch with us at any time and we can follow up with you. So Brett is going to unmute
Yep.
some
So
of you.
yeah. So as folks, if you raise your hand, which we already see a hand raised, you'll be asked then by me to unmute. It'll ask you a question on your screen, and then unmute and ask your question. And then when you're done, mute again. So thanks, and thanks for the patience. I was frozen for a little while. That's why we had issues with this slide. So I'm back.
So there was a hand up, and I'll take that one first. I can't see it.
Yeah, he went away. Where'd that hand go? It was
Jim Byrne, I think.
Jim Byrne. Yeah. So I'm gonna ask you to unmute Jim if you still have a question. So.
Where do you get your eggs from? Are they native Machias River fish?
They are, and they come from the U.S. Fish and Wildlife Service Craig Brook National Fish Hatchery in East Orland, and those fish are of native origin to the East Machias River specifically. Those fish that the eggs come from were captured in the East Machias as Parr, as 2 or 3 year old Parr, and then brought into captivity, raised to maturity, and the eggs were, and sperm were taken from those. So the fertilization happens there at the Craig Brook hatchery. The eggs develop for a period until they have eyes, the so-called eyed eggs, and then those are transported to us.
Great, thank you.
Dwayne, thanks, Jim. Dwayne and Zach, there's a question in the chat from Catherine who says, why do Parr do better than fry? What's the biology behind that? So if you guys both want to kind of go after that one.
Well, why don't you go ahead, Zach?
Yeah, no problem. So in certain habitats, fry can do well. The smaller habitats, those little headwater streams, the advantage to putting fry out is they live for longer in the river. The disadvantage is you sometimes can lose about 90% fry through the very first summer. So by raising the fall Parr, we can try to reduce that 90% figure by a little bit. And since our hatchery essentially tries to operate as an arm and an extension of the river with unfiltered river water coming through, the idea is that the fish in our hatchery get some exposure to natural bacteria and pH changes. And whenever it rains and the river gets cloudy and murky, our hatchery gets cloudy and murky. So basically we're trying to subject our fish to what the same fish are dealing with out in the river. And Parr just give us a little fish to put out to try to give them that much of a head start and also be able to stock bigger sections of the river, parts of the river that are bigger with a fish that hopefully can do better there. I hope that answered the question. But
Thanks, Zach.
That being said, that was part of what the whole Parr project was about, was trying to figure out the difference between those two. When we first started, it had never been done here in Maine before, so we weren't sure what we would see. But over this past decade, we've seen that Parr outperform the unfed fry in the East Machias.
I will say that there has been some Parr stocking over time, but not with a rearing technique like this in the river of origin. And at one point in the distant past, maybe 40 years ago, there were recommendations to use Parr but the practicality of raising them was deemed beyond beyond the ability of the agencies at the time. So that's why this public-private partnership is so important.
There's a few more questions from the chat box, unless there's some people want to ask in. So remember, you can raise your hand with a question too. But there's a question about last year and if there was a red count in 2020, and there was. And I let Zach and Dwayne talk about what we found with that. But there was a red count last year.
Yeah, we did a red count in 2020. But my memory serves me right, we found around 26 reds throughout the watershed, which obviously is a bit of a decrease from the 60 we saw in 2019. But as far as smolt to adult return rate percentages, it was right at our kind of average 2% smolt to adult return rate. There were just, less smolts that went out for that adult return yield.
And I posted a link to a YouTube video on the DSF YouTube page that we filmed during last year's red count. So you can kind of see what that's like. It's a link I posted in a response to Brian. So another question in here, I got a hand raised. So I'm going to go to a hand, and it's Gail. So I'm going to ask Gail to unmute. Gail, you have to unmute and you'll be ready to go. Let's see here.
I can unmute. Oh, good.
There you go. Thanks.
When is the Downeast Salmon hatchery in East Machias open for tourists?
Because of the recent CDC and Maine CDC
I know, Dwayne.
order, we're now open. We're not fully and completely open, but in the after Memorial Day, I think we'll have our systems in place, people prepared to begin hosting. So at the moment, we're doing by appointment. Typically, we're just open for walk-ins, and I think through the summer we'll be open for walk-ins as well.
So Dwayne, I have people coming. Can they go in? They're coming tomorrow. Can they walk in now?
I would suggest against it right now. We're still working out the details. The signs are still up, masks only, and we're not fully prepared. If you want to email me, we might be able to find a time where we can set something up.
Okay. Thank you, Dwayne.
Thanks, Gail. So we've got a question for, I think this is Zach one in the chat box, pretty specific hatchery question. So what is the brood to green egg target and green egg to Parr survival averages?
So U.S. Fish at Craig Brook National Fish Hatchery, the brood stock, which includes maintaining the genetic diversity of that and spawning the fish. The cool thing is, they're always trying to improve what they're doing as well. They made some changes to their lighting systems, and they made some changes to which changed spawning timing and help with the temperature of the hatchery during spawning. Short, this past year, they improved the number of eggs per female, and they also greatly improved the number of green eggs that eyed up or made it to the next stage of eyed eggs. So as far as those percentages, they spawn based on the fish they have on hand, they spawn whatever, and they use a computer program to choose what females and males spawn together, obviously trying to get fish that are as unrelated as possible to spawn. And, so their fecundity and their eye-up rates, they just shoot for as high as they can get. I think last year, I want to say 90% or better eye-up rate. I don't know exactly off the top of my head. Once we take the eyed eggs, from eyed eggs to Parr, our mortality varies depending on the year because we pull in straight river water and the environment's always changing. That can greatly impact what goes on in our hatchery. But we usually have a survival around 70-75% from egg to Parr. I hope that answered the question.
Any timeline for reintroduction of fishing, catch and release? So there's a,
Well, first step is salmon delisted. Well, downlisted and then delisted. So I think there are metrics in the recovery plan, but I think it essentially is you have to go a certain number of, maybe a decade of certain numbers to reach those figures. So we're a little ways out, but that is the goal.
And I think it's important to hold out hope. And the example of the Tyne is just such an inspiring one. And it's not limited, I have to say, to just the Tyne. There are rivers in Denmark and Norway that have been recovered quite successfully and being fished now, where really there was very little fishing or very little fishing success for many decades. So there are success stories. I know in the United States we don't feel like there's been success, and we can't point to it in our own country. But if we continue to learn from others, and I think, and this project is a great example of that. Technology transfer from a successful location to the United States is clearly what's been happening here in the agencies. And these are all, we're all skeptical scientists. We have to be shown that this can work. We have to have faith that there's maybe solutions. But ultimately, after, a decade, the scientific community is saying, yes, this needs to be adopted more widely.
Thanks for these questions, everyone. There's still some more coming in, and they're great. What is the percent of returning adults from natural spawning, but Peter Gray Parr Project ancestry?
We don't know. The bottom line is the fish numbers were so low that at this point, most, if not all of the fish and their parents and probably their grandparents came as a direct result of this program. So through the genetics of the genetics monitoring, we know the crosses, and now we know what parents we can assign those fish back to. However, we don't handle all of the fish. We don't have an adult trap on the river. And that is one of the benefits of going to the Narraguagus now. There is a dam that has a trap there. So we would be able to see directly that the fish that we mark are coming back. So the hope is that they begin to, of course, stand on their own and reproduce in the wild, select their own mates, choose their own spawning locations. And we're seeing that happening. And we're not seeing any loss or erosion of the biodiversity of the population itself. So we have a baseline of allelic diversity, the measure of the diversity within the population itself. And that has continued to be stable, which is a very, very good thing in the long-term picture.
I think Dwayne, you answered the next question, which was concerns around genetic diversity given the low numbers of fish. So I think you kind of alluded to that just there. Concerns around the genetic diversity given the low numbers of fish or salmon in the river.
Yeah.
That is.
Yeah.
Go ahead, Zach.
Anytime you have low numbers of any population, genetic diversity is of keen interest to make sure that you maintain and improve, which is one of the goals of the Parr Project.
The science of genetics is evolving very, very quickly, and conservation biology, so-called, trying to use the remnant genes is really the basis of building back a population. This is the consensus among geneticists. Don't throw away any of the parts of the system that you're trying to build back or the population. And the geneticists have argued over this in Maine with Atlantic salmon, and ultimately come to this conclusion that we do have the ability with even so few fish to build back using those fish. So there is a numbers game here. A big part of this is numbers, putting enough out there to sustain those, protecting them from being lost completely, a particular population, by letting them all go out to sea, for instance. So that's why some of the fish are brought into the hatchery to become the brood stock. So it's like I've said, a live gene bank. In some rivers in Maine, there's begun to have experimentation with combining strains together. So when you have a river, say the Union River in Ellsworth, that really lost its salmon, but you have beautiful habitat if you could, get fish past the dam. So you would then take fish from the neighboring rivers and use each of those to become your new population.
So there's a question on, it says, is there a cap to how many spawns you can release? Have we reached max capacity in the immediate waters near the Parr project? So I think maybe that means how many Parr you can release, I think, but
Go ahead, Zach.
Yeah, so actually determining what the Parr release, determining how many Parr the East Machias River can support, or the carrying capacity of the river, is one of the things we're trying to figure out throughout this project. Of course, that's also very dependent on water levels throughout the year. We've had the fortunate reality of having a number of droughts the past few years during the Parr project. In positive news, our fish are still around and still doing salmon things during those droughts. So they're very resilient species. But yeah, as far as numbers of max, if you're talking about adult fish spawning, bring them on. You know what I mean? We're going to come up the river and spawn from the ocean.
someone asked about how long it took for the tine. So how quick was the tine's recovery, or how long was it? Either way.
The hatchery itself was, and it's like every river, they have a long history and of problems. And in the case of the tine, there'd been a lot of pollution, and then a very large dam built at the top of the river. And part of the mitigation for building that dam was to create a salmon hatchery to mitigate the loss of that number of fish that would have been generated up above that dam site. And then Peter was hired to design and run that hatchery. And he did that for a little over 20 years. So that was built in the 80s, and they're now turning that hatchery off. So this is, the light at the end of the tunnel is, can you actually ever turn a hatchery off, let the fish stand on their own? And it's been a great debate there whether they should do that or not. They're now actually raising endangered freshwater mussels. It's the same species we have here in vast numbers, in fact, but they're raising endangered mussels in that hatchery because they have the space, and releasing fewer fish. So from the early 80s on through until present, that hatchery has been in operation, and I think they began fishing in earnest now 15 or 20 years ago. So it's they were very hotly debated what actually drove the recovery there, because the environment is so complex, and when you start to add things and change things all at the same time concurrently, it's very hard to tease apart what really drove this. So there were some remnant fish there, wild fish. There are a lot of fish swimming right by the Tyne on their way to Scotland. So there's the potential for some straying into that river. They cleaned up the river at the same time. A dam was built, a hatchery was built, and no one collected the amount of data that we've been collecting in this case. So we've really, through this process, vindicated Peter in a sense, because he didn't have the benefit of being able to track exactly what he did and mark those fish that came from that hatchery. So we've answered some questions that have now application to what's going on in England.
That is in the next two questions actually perfectly, Dwayne. So there's two questions around about marking and clipping our Parr and the presence and absence of an adipose fin and what that means. So Zach, you spend most of the time, probably more time than any human on the planet, clipping those fins. So do you want to talk about that?
Sure, pretty simple. As of right now, we do clip the adipose fin off each fish that leaves our facility to document just what Dwayne was saying. The goal would be down the road, once it's accepted in certain places that what we're doing is what's driving the entire population, that eventually we wouldn't fin clip, because obviously the adipose fin's there for a reason, right? So evolutionarily speaking. But as of right now, we do clip them off. It's the fin that they need the least, and it doesn't grow back, and it marks the fish nicely. I also saw a question about if we see any differences in run timing and things like that. And in good, because we raise our fish to be as wild as possible, when we're out snorkeling in the river or sampling in the river, our fish are living right along wild fish, doing the same things wild fish are doing, acting just like wild fish act, and the timing of the smoke run and things like that mirror what has been seen for wild fish in the stream. So that's all good news there too.
Thanks, Zach. I missed that one in there. So just so people know too, we had planned to sort of wrap this up around 8 o'clock. There's a few more questions, so we're willing to keep chatting for a few minutes after 8, but we want everybody to know we're approaching 8 o'clock. So but there's a question here about just, is there aquaculture concerns? So sort of general question for Dwayne. Anything more?
Yeah, that is considered one of the bigger threats to Atlantic salmon, really worldwide, is the effects of aquaculture, fish being raised in net pens primarily, and when they're escape, they can come up and interbreed and really erode the native genetics. And there are many other issues with diseases and behavioral issues and other things. So there is aquaculture happening in the Machias Bay as well as in the East Machias River itself. So just upstream of our hatchery is a Cook salmon hatchery, commercial salmon hatchery. We've not seen any direct issues related to that in recent years. There were some pollution issues in the past. And there have been net pen escape salmon. In some of the rivers, it's really gotten much, much better than what it was 15 or 20 years ago, thanks to a judge who put down the law that there would be a much better management. And so we've not seen as many aquaculture escapes showing up in the rivers as we did a couple of decades ago. So that's a benefit. The Downeast Salmon Federation has opposed the expansion of net pens in Machias Bay. We were the only conservation organization that really stood strong on that and showed up to testify and so on. Those net pens were not expanded. So we're very conscious of that issue. And the monitoring of the genetics of the population, that is what U.S. Fish and Wildlife Service does, is they bring fish into the federal hatchery. They're screening for these other genes.
Thanks, Dwayne. Another question about sort of a timeline on things. So there's a question, is it possible in 20 to 30 years to get a fishery established that's comparable to the Marguerite in Nova Scotia?
Well, I think it is possible. I don't know about a fishery in the sense of angling for them, but it's certainly possible. And we've seen the recovery of other species. Of course, the bald eagle is the one that's always flying around right outside of our windows all the time in East Machias, and we know that those have been downlisted during our lifetimes. So this is long-term work. There's no question about it. And the efforts to protect our rivers, clean them up, deal with the dams, the culverts, the fish passage, the clear cuts, and on and on and on is all long-term work. But there is this element of what I call fixing the fish. So you can fix the river, but if you're putting fish in that just won't survive, as Peter had said, you wouldn't expect them to survive because they're raised so poorly in some hatcheries. That's the other element of what we're working with, the genetics, and then the actual husbandry of the fish, keeping them, preventing domestication as as much as we can.
Well, and Dwayne mentioned time. The other thing to note, there's been some studies out west on salmon populations, and they've kind of determined you need to do whatever you're doing to try to help a species, you kind of need to do for at least 3 generations of that species to really start seeing the effects. Obviously, we're presenting some information before 3 generations have gone by since we started, but it's all pointing to better things in the future. So we're talking 15 years of doing something to really see what it is you're doing. And there's other groups in our shrew, like Project Share, along with DSF, that are doing habitat restoration work in the river. And habitat restoration work is a long-term game as well. So fixing the rivers, like Dwayne said, fixing the fish, working with all partners, like I already mentioned, the changes U.S. Fish has made that has improved aspects of what they do, which helps us through our project. So it really is quite an amazing conglomeration of people working together towards a goal.
I will take the question about climate. I see one there about invasive predators in the rivers. This river system is probably a home to more invasives than any river in the state of Maine. So it's a great place to test this and to see the response in the salmon population, despite the fact that we have largemouths and smallmouths and pickerel and perch, and the list goes on, is really remarkable. That doesn't mean we're dismissing the fact that those fish are a problem. They're absolutely a problem, and we would like to study that. We don't want to study it. We want to, somebody say, study it to death. We want to get rid of those fish, and we're trying to find ways to do that. And in fact, we just had signs made to put up in places where anglers frequent, saying these fish are invasive, please remove them if you're catching them. With some people, it's not going to be particularly popular, of course, but in the river itself, there are many places, small streams, where we can remove bass and pickerel through angling, for instance, to a degree that could be really significant. The issue of climate is worldwide. Of course, we know that. This is a global issue. We are seeing problems with temperatures and very strange hydrology. We're in a significant drought right now. We had almost no snow last winter. And again, as Zach pointed out, despite the drought years that we've experienced during this project, we're seeing really pretty good results. So against the issue of climate, native, non-native invasives, with the habitat work that we've done and with the fixing of the fish and the stocking and the number of fish we're putting out, we're able to still see a very positive response. The Eastern Maine is a very cool place, cold, in comparison to other places in New England, certainly. And we have a tremendous amount of groundwater here. So there are spring holes, groundwater refugia, so-called, where these fish can go during those hot periods. And we're showing with these results that those fish are finding a place to survive. And some of these streams are down to just a half an inch of water spread across a 10-foot wide stream, and we'll look under a rock and there's a wild Atlantic salmon that looks pretty healthy in the middle of the summer, just nose right into a cold little spot. So the groundwater is going to be the last part of our hydrology that will be affected by climate. And we have a lot of groundwater in eastern Maine, so that's one hopeful piece. We also know our neighbors in Nova Scotia are having pretty good success. Someone mentioned the Marguerite, the West River in Sheet Harbor. There's been a project there where with use of lime in that river system, and the populations are really increasing there, despite, again, climate and these other issues. Maine just passed a law that allows for us to now do liming of our streams. DFS has been experimenting with use of clamshells in the East Machias River to sweeten the water, add calcium. And so it's a piece of the habitat restoration that we think we can tackle that will give the salmon that much more of an advantage. And the fact that we have a lot of clamshells in the area, of course, is helpful. Someone says they look forward to progress on the Denny's in the future. We have a lot of great rivers in this area. The Denny's was a tremendous salmon river. The Machias, the main Machias, the Narraguagas, Pleasant. It's our intention to repair and restore all of them. And I'll add to that the Union River. And that is a river that's been broken for a very, very long time, since 1907, when the dam at the head of tide was built without a fishway. And of course, there were problems before that. So to be able to export this technique to the Denny's or the Union or anywhere else is really what the agencies themselves are now saying. It's what we've been saying for some time. And with the funds, we have an open door to run with this. And I think Peter and Ori would be very pleased to see what's happened after all these years of fundraising and scrambling and the sleepless nights of, the hatchery manager whose job is 24/7 when you have fish in the facility. If the power goes out or there's a pump that breaks, Zach and others are Johnny on the spot. And so we have the right people doing this work as well. But I just want to say thank you again for attending. I wish we could spend more time with the questions. Please send questions. We will be open very soon for visitors by appointment, especially at the moment, but we'll have our open door ready to go, no doubt, in the next couple of weeks. So please come and visit as well and see for yourself what this looks like. Thank you all again. Thank you, Brett, for organizing the technology.
Yeah, sorry everyone for the little bit of, if you were held in the waiting room, I'm sorry. We got you in eventually, but we were trying to bounce back and forth between screens there. Take care all. Have a good evening.